Mr. Gibson here. Today we're going to begin a new unit that was going to look at two types of functions, linear functions and quadratic functions. Now, you've studied both of these before in your Math 1 and Math 2 classes, so today's lesson will be a basic review of linear equations. Then we'll get into some modeling using linear equations, do the same thing for quadratics. We're also going to introduce the concept of transformation of functions. And we'll apply that both to linear and quadratic functions. So let's look at our objectives here for today, okay? We have two. The first is, how do we determine the slope of a linear equation? And the second is, how do we write the equation using the slope-intercept form if we're given certain information? So let's define what a linear equation or linear function is. So an equation whose graph is a line is a linear equation, right? Linear contains the word line in it. That's where the name comes from. So if we graph an equation, let's take an example, y equals 1/2 x plus 4. That is going to give us a nice straight line if we graph it. And we'll get to how we graph it in a moment. But let's look at some important characteristics when we graph a linear function. The first is the y-intercept. This is the point where the line crosses the y-axis. In this case, the y-intercept would be at 0, 4. Notice if it crosses the y-axis, our x value is 0. We also have the x-intercept, the point where it crosses the x-axis. And here in this case at -8, 0. So notice for the x-intercept, our y value is 0. Okay, so we have our x and y intercepts. And then the other key attribute is the slope of the line. And you remember this, right? We often define the slope as the rise over the run, right? How far do we have to go up and over to go from one point on the line to the next point? So how do we find the actual slope? If we have a line with 2 points on it, we can find it by taking the ratio of the vertical change to the corresponding horizontal change. Another way of saying rise over run, okay? So the vertical change, right, is how far do we move up from one point to the next in the y direction, the vertical direction, divided by the horizontal change, which is how far we move to the left or right to get to the point along the x-axis direction. So that's where the terms rise over run comes from, right? The rise or vertical change divided by the run or horizontal change. Now, we can actually calculate that by simply taking the difference in the values. So for the rise, since it's the change in the vertical height, it's going to be the difference of the two y coordinates, so y2 minus y1. For the horizontal, it's simply the difference of the two x values of our x and y coordinates, so x2 minus x1. Now, you can see I've labeled in the graph here x1, y1, x2, y2. It doesn't matter which point you call x1, y1, or x2, y2, as long as you're just consistent, right? That we don't get the x value of one point mixed up with the y value of another. Either way, you'll still come out with the same value of the slope. So let's look at an example here. We have these 2 points, -2, -5, and 4, 3. Let's find the slope through those, okay? So we're going to plug in the y2 and y1 values, right? So y2 is 3, y1 is -5. So notice we put the parentheses around it. And then our x2 value is 4. And our x1 value is -2, again, using parentheses since we are going to have two negatives there. All right, so we know integers, right? If we're subtracting a negative, that's the same as adding a positive. So we'll get 8 on the top, 6 on the bottom, and then always ask yourself, can I simplify? And in this case, yes, we can divide both by 2, we get 4 over 3. So what does that actually mean on our graph, right? It says we're going to go up 4, as the red line shows, and then over 3. And we can do that, whoops, we can keep doing that, right? We'll arrive at the other point if we went up 4 more, 1, 2, 3, 4, and then over 1, 2, 3, we'd arrive at our second point here at 4, 3. let's look at one more example. Okay, here's 2 points. Let's put the graph through it, and let's find our slope. So in this case, our y value for this top point up here is 7, and the y value for the lower point is a -5. So 7 minus a -5, and then -1 minus a +2 for the x values. So we get 12 over -3, or that simplifies to -4/1. Now, when we write a slope, we could write it as just -4, but putting it over 1 reminds us that it's a ratio, right, of the change in the y value over the change in the x value. So again, this case, it says we would go down 4 and over 1, right? Down 4 and over 1. Now, we have some special cases of lines, right? What happens when they are vertical or horizontal? So let's step through these. If we have the case where the line is vertical, we say that the slope is undefined. Now, why is that? Notice there is no change in the x value for a vertical line, which means we would be dividing by 0, right? Because we're going to take x1 minus, or x2 minus x1. They're both going to have the same x value and give us 0. A horizontal line has an actual slope, but it has a value of 0. Now think about it this way, right? There's no change in the y values. They're constant across that horizontal line, so that our numerator would be 0, and we can have a slope of 0. A couple more cases. What if, how do we compare the slopes of 2 lines that are perpendicular to each other? Well, it turns out their slopes, if we multiply them together, give us a -1. Or another way to say it is that the slopes are negative reciprocals of each other. So if we had a slope of 3/4, right, for one line, the perpendicular line would be -4/3. We just take the reciprocal and then the opposite of that. And parallel lines, this one's pretty obvious, right? The slopes are going to be equal to each other. They're going to have different intercepts, but by definition, if they're parallel, they're going to have the same slope. All right, let's look at one form of the equation of a linear function that we're going to be using a lot here. It's called the slope-intercept form. Okay, so it has this form, y equals mx plus b, where m is the slope of the line, and b is the y-intercept, the y value where the line is going to cross the y-axis. That's this red dot up here. Okay, so if we know those two things, the y-intercept and the slope, we can write the equation for the line. So let's do it for this example up here. Let's put some actual values, right? Our y-intercept is at 0, 2. So that means our b value is going to be 2. The slope, well, rise over run. That's pretty easy. We can just count the squares. So we go down 2. So that's going to give us a -2. And then we go to the right 4. That gives us a +4. So -2 over 4 gives us a -1/2. So now we just need to put those values into the slope-intercept form. We put in -1/2 for the m value times x, make sure you keep the x in there, plus our y-intercept value or b value of 2. Let's try one more here, okay? So our y-intercept is 0, -4. So our b value is -4. Let's determine the slope, right? In this case, we're going to go up 4. So that's a rise of +4. And we're going to go 3 to the right. That's a run of +3. So we get a slope of 4/3. And now we put that into our standard form for slope-intercept. So 4/3 for m and -4 for b. Now let's write an equation where I give you this information and then we're going to graph it. Okay, so it has a y-intercept of 0, -4, and a slope of 7/4. So if you're given this information, right, it's very easy for us to write the equation. We're just going to plug it in. There's no calculating of slope. It's already been done for us. But how would we graph that? What would that look like? Okay, so we're going to first put a point at our y-intercept, so 0, -4. And then all we need is a second point to draw the line. And we'll find that second point by using our slope, which is 7/4. So which means we're going to go up 7 and over 4. And if we do that, we can now locate a second point on the line. And we now know where our line, what it looks like, the 2 points that it goes through, the y-intercept and then another point on the line. Okay, so that's it. That's the basics that we're reviewing today. Again, this should look familiar to you. The rest of the lesson are some practice problems. So if you want to pull out your whiteboard on the graphing side, you can get a little more practice here before you start the assignment today. So let's look at some of those problems. So first, let's find the slope using the 2 points. Okay, so here's our 2 points. We have 6,4 and -2, -8. Here's our line through those points. So what's the slope going to be? Let's use our formula, y2 minus y1. So y2, we're going to put in as -8, the lower point, and +4 for y1, -2 for x2, and 6 for x1. So if we simplify all that, we get -12 over -8. So negative divided by negatives can give us a positive, and we can divide both of those by 4. So we get a slope of 3/2. And you could check that on the line here, right? We would go up 3 and over 2. That would keep us on the line. Okay, you try this one. Just pause the program, see if you can find the slope, and then resume it and see if you got it right. All right, let's plug it into the formula. This one's pretty easy, right? Because one of our points is on the origin. The values are 0. So all we really have to worry about are the y2 and the x2 values. So 6/2 gives us a slope of 3, or we could write it as 3/1. Let's try one more. All right, here we go. y2 minus y1 over x2 minus x1. So we've got a -3 for y2 minus a -1. Notice how I put the negative in parentheses so we don't lose a negative. And then x minus, or 8 minus a -2. So we get a -2 over 10, which gives us a -1/5 when we simplify. Okay. All right, let's get a little practice graphing. Can you graph this line on your graphing side of your whiteboard? So remember, the first step is, can we identify the y-intercept and the slope? So the y-intercept is 5. That's our b value. So it's going to give us a point right here on the y-axis of 0, +5. And then we'll use the slope to find another point. So we know our slope is -7/4. So we're going to go down 7. And then we're going to go 4 to the right, the positive direction. And that gives us our slope of -7/4. And now we can draw our line through it. Okay, let's see if you can graph this one. Okay, here we go. B value, y-intercept is -6. So there's our point on the y-axis down at -6. And our slope is a 5 over -3. So we're going to go up 5. And then because it's a negative run, we're going to go 3 to the left. Okay, so there's our line. All right, let's do one more here. See if you can graph this. Okay, here we go. Our b value is 2, right? So let's put that on the y-axis. Our slope is 4/3, so we'll go up 4 over 3, and there's our line. Now, if I give you the line, can you write the equation? Let's try one of these. So what do we need to know? We need to know the y-intercept and the slope. So the y-intercept, right, that's easy by inspection here. We see it goes through the y-axis at +3. And our slope, we can just count on the graph here, right? So we go 3 to the left, that's going to be our run. I'm sorry, -4. So 4 to the left, that's our run. And then we're going to go down 3. So that's -3. Now you could have gone up 3 and over 3. Either way, we're still going to wind up with a +3/4. So we just put that into our slope intercept form, 3/4 for m and 3 for the y-intercept. All right, you try another one here. Okay, so this one's interesting, right? This is our horizontal line. You remember what case that gives us? Is that undefined or is that a zero slope? Well, let's use our process here. So the y-intercept is -2, right? Goes through the y-axis at -2. Here, the slope, right, rise over run is 0 because there's no change in the vertical direction, only change in the horizontal. So our rise is going to be 0, even though we have a value for the run. So what does that mean? If we put 0 in for the slope, it basically means that this term where it's the slope times x drops out, right? It's 0 times x is just 0. So it simply leaves us with the equation of a horizontal line, y equals -2, because every point along that line, y is equal to -2. We don't care what the x value is, right? The x value can be any value, just that y always has to be -2. Okay, that's it. So you know how to find the slope of a linear equation, and we got some practice using the equation to graph the line, find the slope from it. And if I give you the graph, you are now able to write the equation. All right, that's it. Start on the assignment.